This is part 20 of 8086 instruction set, and we will be seeing control transfer instructions based on conditions, that is conditional branch. And the conditional branch instructions in 8086 are variants of jump and loop instructions, and the variation here is either based on the condition of the status flags, okay, whether it is set or unset, or based on the type of operands used in the previous instruction. Okay, and we will see both these cases. And how the jump is done? Jump is done by changing IP. Okay, not CS, only IP, because the conditional branch instructions in 8086 are actually used only for short jumps. Okay, so this is this table, right? This table indicates the variants of jump instructions which just sees only a bit or a register, or considers only a bit in flags register or a particular register to execute its jump. Okay, so let's see which all flags or the flags register are considered. So we have the overflow flag being considered, sign flag, zero flag, parity flag, and we have a special case of CX register also being considered. Okay, so as a flag can be in any two states, either set or unset, we have two instructions per each flag. Okay, so J, or the jump if overflow instruction, will perform a jump if overflow flag is set. The jump not overflow, it performs a jump when overflow flag is unset. Similar is the case with other flags. Now coming to the case of CX register, we have instructions JCXZ, which performs a jump if CX is 0. Okay, so these are the variants of conditional jump instructions which performs a jump taking into consideration the status of bits in flags register as well as the condition of CX register, that is a count register. Now usually when we write a jump instruction, right, it actually follows a particular instruction. Either, most probably it will be a compare instruction. It will be comparing two operands, and based on the result of compare you will be actually writing a jump to a label. Okay, suppose that you have a compare instruction and the operands used in the compare instruction are unsigned operands. Okay, so in such a case, in order to write a jump into the next line, you can consider all these instructions. That is, if unsigned operands are setting some flags, right, then the jump allowed are all these things. Note that in each row, right, the jump instructions which are grouped together has got the same opcode. So it means that they perform the same operation, but they are just given different names. So you can use these instructions within a row interchangeably. So JB, that is jump if below, is equivalent to jump if carry, and it is equivalent to jump if not above or equal. Okay, so suppose that you are performing comparison between a destination operand and the source operand, and if you have to perform a jump if destination is less than the source operand, right, in case of unsigned operands, you can use any of these three instructions. Okay, jump if below, jump if carry, or jump if not above or equal. Similarly, if you have a destination that is greater than the source, and if you need to perform a jump based on that, you can use jump if not below, jump if above or equal, jump if not carry. Okay, so these two sets of instructions are dependent on the CF or the carry flag. Then if you have a compare instruction where the result, right, if it is below or equal, that is less than or equal, and if you need to perform a jump, you can use JBE or JNA, and they actually check on CF and ZF as shown here. And if based on a compare, right, or similar instructions, if you need to do a jump if the destination is greater than the source, right, you can use jump if above or jump if not below or equal, and the flags used are CF and ZF. Okay, now coming back to signed operands, right, again for signed operands we have a set of or grouping of jump instructions. As in the previous case, the jump instructions written within the same row are equivalent or have the same opcode, and only their mnemonics differ. Okay, so if based on the compare, right, if the destination is less than the source, and if you need to perform a jump to a label, you can use either JL, that is jump if less, or jump if not greater than or equal for signed operands of compare. Okay, and the flags used are sign flag and overflow flag. Then if destination is supposed to be greater than your source, right, and if you need to perform a jump, then you can use jump if greater or equal, or jump if not less. Okay, that is if the destination is greater than or equal to. Okay, then if the destination is supposed to be less than or equal to, we can use these two instructions, that is jump if less or equal, jump if not greater, and they depend on ZF, that is zero flag, sign flag and overflow flag. Then this one is the case of greater, destination is greater than the source. Note that all these things are applicable for signed operands. Okay, operands expressed in 2's complement notation inside. So that finishes the jump based conditional branch instructions. Now we have loop based conditional branch instructions. Okay, and the condition here is apart from CX, certain flags are checked. Only the zero flag will be checked. Okay, so we are going into that. So when the zero flag is set or it indicates a zero, okay, based on that we have two loop instructions, that is LOOPZ and LOOPE. Okay, so remember that LOOPZ and LOOPE has got the same opcode, so their mnemonics only differ. Okay, so if at a particular line, if you need to jump back to a previous line or jump forward to a line to execute a loop, right, LOOPZ and LOOPE can be used if the loop has to be executed when zero flag is set. Okay, so in short it means that if the zero flag is set based on a previous instruction, and only then if you need to execute a loop, you can use LOOPZ or LOOPE. Okay, so this is the algorithm of LOOPZ. So at the point of the loop followed by label part, what happens is CX will be decremented, and as usual checking whether CX is 0 is done. If CX is 0, what happens? We won't do the loop, right? Then so apart from the normal check of CX is 0, you also check whether the zero flag is set, okay, because it is LOOPZ or the LOOPE as the case may be, and if both the conditions are true, then only we will do a jump. Okay, if either one of the condition is true, we won't jump, we will just resume with normal sequential flow. So that is the case of LOOPZ and LOOPE, that is you will do a normal loop based on CX when zero flag is set. Okay, now we have the case of zero flag being unset. So if you want to execute a loop based on the counter CX when zero flag is unset, you can use LOOPNZ or LOOPNE. Okay, so loop not zero or loop not equal. Okay, so how this works is at the point of the loop statement, as in the normal case, the counter CX register is decremented and the condition whether CX is 0 is checked. If CX is not 0 and if the zero flag is unset, then only you execute the jump. Okay, but on the other hand, if either of these two conditions is not met, then you won't execute the jump, you will just proceed with the sequential flow of execution. So that is the case of LOOPNZ and LOOPNE. Okay, they will help you to perform a loop in the condition, with the precondition that the zero flag is unset.